Hey guys, welcome to my workbench. Let me show you what I've been playing with. Thanks to Xerotolabs, a fellow YouTuber who introduced me to this cool little chip. This is an 8-channel I/O expander, and it does exactly what it sounds like. It takes 2 I/O pins from the microprocessor. This could be an Arduino or an ESP8266 or whatever microcontroller. It uses I2C protocol to drive 8 I/O pins using just those 2 lines. Furthermore, you can have up to 8 of these on the same 2 I2C lines for a total of 8 times 8, 64 I/O pins being controlled by just 2 I/O pins from your microcontroller. I think that's pretty awesome. If you're interested, stick around and I'll share what I've learned about this cool little chip. I've wired up 2 of those I/O expanders here on a breadboard, and instead of an Arduino, I'm using this guy. You might recognize him. He is the Model 1 of the ESP8266, and this model only has 2 usable I/O pins. But as you can see, I'm driving 16 LEDs using those 2 I/O pins. You know the secret. So this is just a cell phone charger power bank supplying 5 volts onto this guy here. He converts the 5 volts to 3.3 volts, which the ESP8266 require. That's just a power switch. And this is a push button that you use to program this chip. And this is a USB to serial adapter, commonly referred to as an FTDI, that will take code from the PC, transfer it to the ESP8266. So this is only needed for programming it. So let's see it work, huh? So this sketch here is just a sample sketch that I wrote to do binary counting. These 8 LEDs are controlled by this I/O expander, and these 8 LEDs are controlled by that I/O expander. Basically, it shows that each one of those LEDs are completely independent from each other. We could turn on and off any of those 16 LEDs, or if we have enough of these, any of the 64 LEDs. So that's pretty neat, but check this out. So there are 16 switches here, 8 connected to this one and 8 connected to that one, connected to another ESP8266 Wi-Fi module, and you know where this is going. So he is actually going to transmit the state of these switches through Wi-Fi to this guy, and it will reflect it here. Let me show you. You guys ready? So we'll turn this guy on. He is a WebServer actually, so he's going to be listening for commands coming from this guy. So I'm gonna let it kind of like boot up, so connect to my Wi-Fi access point and stuff. If we hook it up to the USB, we could actually see some messages. The same thing goes with this one. So now he's looking for the Wi-Fi access point, and then as soon as that's ready, he's going to wait for the buttons. And as soon as we press the button, it sends it out there. And basically, any of these buttons work. The cool thing is, because they are independent buttons, I could press as many as I want in any combinations I want, and I think it's just pretty dang cool that you could send all these 16 bits all at once. In theory, if I have 8 of these and 8 of those, we could have 64 inputs and 64 outputs. I'll include the code in the description. If you guys have any questions, post them in the comments and I'll try to answer them. Thanks for watching, guys. I'll talk to you guys next time. Bye-bye.